Hello? Oh, there you are. All right, those of you at home, here's your warm-up. 4 runners go out for a jog, each taking a different route. Write their names in order from the fastest to the slowest jogger. How did you know to put them in that order? You're going to want to pause the video, work on that, and then unpause because we are ready to go here. So let's do this, guys. Let's see here. I'm going to snap these up, grab those, behold your future. Okay. Waiting. Table E. Table C. Okay. Let's see here. Liam, who is the fastest, do you think?
Luke.
Luke? And then who is the next fastest?
I didn't finish the thing, but is it Henry?
I don't know. Let's find out. Okay. Who's next?
Summer and then Melissa.
Summer and then Melissa? How many of us got that same order? How many of us got that same order? Okay, so that's not necessarily a bad sign, but let's see. How did you get that order, Liam?
I just divided the minutes.
Tell me, divided the minutes by what?
I don't
I'm
know.
glad we're talking. This is a good thing. This is a good thing, right? This is how this works. So let's see if we can get a different opinion here. And I would love to get that from, let's see here. I'm going to draw empty seats for a minute. Let's see here. Mira, what was the order that you got?
Oh, great question.
We're not sure how to do this. Okay, I love it. Let's do it. That's okay. That's what we're here for, right? So we're going to go ahead and do that. Let's go ahead, and I'll tell you what. Let's just get into it. We're going to use this as part of our notes then. Here we go, guys. It is the 57th day of school. You know that 57 is a Grothendieck prime? Well, there's definitely a serious problem with the Grothendieck prime. It's not even, but there's only one even prime.
It is even.
Nope, it's odd for sure. The problem with the Grothendieck prime, guys, is that it is not prime. It is 3 times 19. So basically what happened was there's a professor named Professor Grothendieck who works on mathematics that are such like a high order of mathematics that he doesn't even use numbers in his math anymore. And he was like, consider a prime number like 57, but it's not actually. So now they call it a Grothendieck prime to make fun of him. It's National Accountants Day. Does anybody have any accountants in their family? Any accountants in their family? Sorry.
My dad?
Your dad, who is he accountant for?
No idea.
That works. I love it. Yeah, Luke. Your aunt's an accountant. Do you know who she's an accountant for?
No.
No, that's okay. Anybody else got one? Henry.
My dad.
Your dad, do you know who he's accounting for? Accountant for? That's okay. Maybe you should ask. You should ask today. Say Happy Accountants Day. What the accounting? An accountant? Well, can someone explain what an accountant is? Someone who's got an accountant in their family, maybe? I'm glad we're talking. An accountant is somebody who handles the money for a business. Handles the money for a business. Penny.
My dad's an accountant.
Your dad's an accountant. Do you know for whom? Oh, you got to find out. Go find it.
No, wait. I don't think he is one.
Oh, that works. Go find out today. Yes, Josh.
My friend's mom.
Your friend's mom. Do you know what she's an accountant in? For?
I know she was like,
Shh. That works. That's okay. That's okay. Again, it's National Accountants Day, so today would be a nice day to find out. Luke. Oh, a bank accountant at a bank. That works for sure. Okay, let's see here. Thomas, you got one more.
well, my grandpa was a bank accountant.
Yeah, that's awesome. Very good. Let's see here, guys. What's our first essential question? And I would love to get that from Miss Jane. How can I use division and units to calculate / interpret unit rates? Table F, let's get those voices off, please. Having to ask you guys an awful lot today. I'm hoping that this is the last time. Bluey character breeds through the AKC. That is, I'll give you some Bluey characters and also the American Kennel Club's official description of that breed of dog. And then you're going to tell me what that is. Bluey, Bingo, Chili, and Bandit are all the same breed of dog that are always alert, extremely intelligent, watchful, courageous, and trustworthy, with an implicit devotion to duty, making it an ideal dog. Whoever wrote Healers, I need more. Blue Healer is the correct answer. Blue Healer. We would have all. That's true, but they're still technically the brand, the breed. Can I get you in 5, 4, 3, 2, 1? The name of the breed is the Blue Healer, but it actually is has another name. It's an Australian cattle dog, and then fruit's apple. Okay. Moving, ladies and gentlemen. Okay. I do need you guys back up here in 5, 4, 3, 2, 1. Ladies and gentlemen, if we're going to get into a big argument about all of these this week, I can just go ahead and cover it up and we will not do them. And that's fine with me. That's not acceptable, guys. Like, we're not having these arguments right now. You can argue about that later. Right now, we're trying to meet our learning goals, and that is not helping it in the slightest. Okay, we're having kind of a rough start of the week. Can we please just take a deep breath, let it out, and let's see if we can do this. I mean, there's a few ways to teach this lesson, and one of them's, I think, a lot more fun than the other ones, but I sure can just come up with stuff that's way less interesting and probably be more effective, so I can just kind of keep a better eye on you guys if we're just going to try and chat over me every chance you get. So please stop that. Okay, let's see here, guys. So let's see, with a thumbs up, how many people here think they've got this list in the correct order from fastest to slowest? Thumbs up all the way, thumbs down, no idea how to start it, then dial it somewhere in between. Where is everybody? Where is everybody? So we're seeing quite a few people who have at least got some ideas on where to start. So let's see here. Annie, what would be your first step in finding out who is the fastest? Divide the miles by the minutes. Let's try that. So Melissa goes 5.31 miles divided by 30 minutes. And we're going to grab our calculator and do that because I'm not interested in doing that without a calculator. Okay, so grab your calculators if you don't have them already. You're going to need them today for sure. TI SmartView TM emulator software for the TI-30X/TI-34 multi-view. TM calculators, Texas Instruments, validating software license, ... I'm sorry, I coughed in the middle. There you go. So we're going to do 0.31 divided by 30. So you get 0.177. Now here's the thing. Really importantly, 0.177 miles per minute. There is a rate that goes with that. Table C. I'm going to ask you guys an awful lot today too. Relax. Focus. Okay. That's really important. The units are very important. Let's see here. Can I get a little help then? Let's see. River, how would I find out how fast Henry was going? Right, and importantly, that's miles divided by 70 minutes. So 10.92 divided by 70, 0.156 miles per minute. And then we do the same thing here, right? 18.8 miles divided by 100 minutes. 18.8 divided by 100 is 0.188 miles per minute. And finally, Summer is going 16.02 miles. It's a long run in 90 minutes. 16.02 divided by 90, and that's 0.178. Okay, so now I have all these unit rates. Now I have all these unit rates, and I think that these rates tell me who the fastest is, who the second fastest is, who the third fastest is, and who the slowest is. So when I say teach, I want you to say, okay, how are these numbers going to help me get these runners in order from fastest to slowest? Teach! On the Chromebook still. You would still put it on the Chromebook learner board. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Alrighty. Tice, who is the fastest? Luke, okay. Who is the next fastest?
Summer by .001.
Summer, and then who's after Summer? Melissa, and then who is last? Henry, okay. How many of us got that same list and got that figured out okay? Did anybody happen to do that a different way? Did anybody happen to do that a different way? Because I'm going to show you something that can happen here. Put your pencils out. I'm not going to make you write it. But I do want you to look, because it sounds like most of us did it this way. But 30 minutes divided by 5.31 miles. Let's see here. So 30 divided by 5.31. Oops, that's a negative. Divided by 5.31 is about 5.65. About 5.65 minutes per mile. Let's see here. Then the next one was 70 divided by 10.92, which is about 6.41. About 6.41 minutes per mile. 100 divided by 18.8 is 5.319, about 5.319 minutes per mile. And then down here, it's summer was 90 divided by 16.02, which is about 5.618 minutes per mile. 5.618 minutes per mile. I heard somebody say that the fastest person is the person with the biggest number next to them. Is that still the case here? Yes or no? I'd say what? Everyone I would say?
No.
No, that is not the case. Can you guys talk to me? This should have the same order. Like, this is the same information. So what's going on? Why do the big numbers mean faster? Or why do the big numbers mean slow and before the big numbers meant fast? Teach, teach.
It's minutes to miles. It was miles to minutes.
Yeah. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's make sure we're talking about the math and not whatever that was, please. For the most of us, though, that was a really good countdown from 5. I appreciate most tables doing the right thing, and I appreciate you guys talking about the math. I think you guys do deserve a point for that.
Oh, yeah.
Let's see if table E can do a little better next time. Okay, let's see here, guys. What's the deal? Tommy, how come the small numbers are better now? That's right. This is how many minutes it takes to run a mile. So this always happens every year. I just pick 4 of you guys at random, and I put you in here. And then when we get to the slowest, which in this case was Henry, everyone's like, ha ha. But can you run a 6.4-minute mile? I can't. No way. I sure can't keep that pace for almost 11 miles. That's crazy. Like, that's bananas. Like, Summer needs to. Summer's like a future Olympian with this kind of a split, I would say. So, I would say, guys,
And we are not.
can I get you in 5, 4, 3, 2, 1? Got a pencil? Today's topic is ratios, rates, and food safety. Well, maybe. I don't know. I'll tell you guys right now, the more you talk over me, the less likely I am to just, or I'll just cross off that first part and we'll do. Because the first one, it's not going to be that interesting. Let's talk about this in terms of like a ratio. A ratio would be something like, what's the ratio of boys to girls in this class? When I say teach, I want you to say, okay, what's the ratio of boys to girls in this class? Go ahead, get counting, and teach. 3, 4, 5, 6, 11, 12, 13, 3, 5, 6, 7, 8, 10, 11. Oh, not counting me, not counting me. I'm talking students. Just talking students, just talking students. I don't count, I don't count.
Boys to girls, we're outnumbered by
6,
We're
7, 8,
outnumbered.
13, and then 3, 4, 6, 9, 10, 11, 13. Yeah, I think I did that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, can I get you in 5, 4, 3, 2, 1? How many boys do we have in this class? 13.
Well,
Now hold on. How many girls do we have in this class? 13. So, guys, this is actually kind of beautiful. This wound up perfectly even. By the way, when I asked how many boys were in the class, I heard a couple of boys say 12. All the girls said 13. And then when I asked how many girls in the class, all the boys said 13, but a couple of girls said 12. Can someone tell me why that happens sometimes? Bennett. Sometimes people forget to count themselves. So the ratio of boys to girls is 13 boys to 13 girls, which is kind of amazing because the thing is that this really works as a fraction also. 13 boys divided by 13 girls. Does that reduce everybody? Yes or no? I'd say whatever, and I would say, yeah. So you could say there's 1 boy per girl in this class, and that would be what's called the unit rate, which means we can write equivalent ratios to this. So like, for example, 13 boys to 13 girls, that would be the same as, it seems silly, 1 boy to 1 girl, or 8 boys to 8 girls. That's the idea. Those are ratios. If it's in a fraction or if it's a whole number next to the unit rate like that, that's a rate. And then if they're next to each other with that colon, that's like that's a ratio. So we're going to write some ratios today about some food safety regulations. So let's get to it, guys. All right, ratios, rates, and food regulations. Let's talk about pepper. Who likes freshly ground pepper? Who likes to put that fresh ground pepper on their food? I know I do. Hey, did you guys know that the FDA allows a ratio of 4 rodent hairs for every 50 grams of pepper? Yeah, the FDA will go to pepper places and they'll take 50 grams of pepper and they will count all the rodent hairs in there. And as long as there are 4 or less, ship that pepper, it's fine. So, when I say teach, can I get you in 5, 4, 3, 2, 1? Will you guys write a ratio and a rate? Table C, I'm having to talk over you guys an awful lot. It really isn't working for me today. Please, that is quite enough. Just stop talking over me. I'm giving you guys directions. and I need you guys to be able to hear them, okay? Okay, guys, I want you to go ahead and write this as a ratio. That's with the colon, and a rate. That's with the fraction. And come up with an equivalent ratio and rate for each. If this first time you're like, I don't know how to come up with an equivalent ratio and rate, we'll talk. P.S. I looked it up. These are the accurate numbers. These are 100% the correct numbers. I looked it up on the FDA. I look it up on their website every year. So let's see what happens here. Give it a shot, and here we go. Squeak, squeak. Achoo! Peach! Those are your mice. Those are the mice inside of your pepper.
Why did you ruin eating pepper?
I'm doing the best I can. Go ahead and let's get to work. Perfect.
So for every 4 road hairs, there has to be 50. So every 50 grams of pepper, there has to be 4 road.
Well, there can be, yes, exactly. There can be up to 4 rodent hairs. 3 rodent hairs would be even better.
But the thing is, should there be any
There, you know what? You'd be surprised. It is nearly impossible to keep this stuff out of food. And don't worry, these facts just keep getting worse. All right. Can I get you back up here in 5, 4, 3, 2, 1? Excellent countdown from 5. Thank you so much. Well, almost. Again, excellent countdown from 5 for most of us, guys. Thank you so much. However, table E did seem to have their conversation continuing after I've asked them multiple times to not. So please stop table E when I count down. I need you to settle in and not be talking through our lesson. Archie, what would be a ratio that you could write for this?
I did 4 rodent hairs to 50 grams of pepper.
Perfect. 4 rodent hairs to 50 grams of pepper. Were you able to come up with an equivalent ratio?
For every 1 rodent hair, there's 12.5 grams of pepper.
Ooh, 1 rodent hair to every 12.5 grams of pepper. I love that. Did someone come up with a different equivalent ratio? Did someone come up with a different equivalent ratio? What'd you come up with, Tice?
Oh, I came up with 2 rodent hairs to 25 grams of pepper.
Beautiful. Awesome. Okay, what about as a rate? How can I write this as a rate, Josh? I'm glad we're talking. So to write it as a rate, we're going to use division. So Josh, just tell me 1 divided by the other, and it really literally doesn't matter which one. So 4 rodent hairs divided by 50 grams of pepper. And what this turns into is 4 divided by 50. Well, let's do it. 4 divided by 50 is 0.08, which is to say you can have 0.08 rodent hairs per gram of pepper. You could have gone the other way as well, 50 grams divided by 4 hairs, and that would have given you a unit rate from what Archie was saying, which is 12.5 grams per hair. So when you eat 12.5 grams of cracked pepper, chances are you have consumed 1 rodent hair. That is about right. Oh, okay, that's good to know, Penny. All right, can I get you in 5, 4, 3, 2, 1? Shh. Voices? Was there a question over there, River? Well, because pepper comes from plants, and rodents live there, and when you harvest them, chances are you suck up a few of those puppies up with them. It happens. There's nothing you can do about it. All right, berries. Yum. Yay. Mmm, berries. Did you know? Did you know that the FDA allows a ratio of 4 insect larvae to every 500 grams of blackberries, blueberries, strawberries, and raspberries? Write this as a ratio and a rate and come up with an equivalent ratio and rate for each. Yum, berries, teach. Yum, yum, yum. Mmm. Mmm. Yum, yum. Delicious. Go ahead, guys. Let's come up with some math, though, pal, shall we? This is all fun and good. I'm glad we're grossed out, but I want you guys to also be working, please. Why not? Yeah.
I'm beyond disappointed.
They're allowed. They're allowed to have up to 4 insect larvae for every 400 grams of blackberries, blueberries, strawberries, and raspberries. Mmm. You know, when my parents had a cherry tree, and they brought over a bunch of cherries, and we were just munching them down. But Autumn was too little to eat them in one bite, so she would take a little bite out of each one, and then like take the pit out, and then take another bite. But so she takes a little bite, and she's like, "Hey, there's a little worm in this one," and we were like, "Oh, gross!" And we tossed it aside and gave her a different one. She bites it. There's a little worm in this one, and there was a little worm in every single cherry, and I'd eaten like 6. Mm-hmm. Protein, it's good for you. All right. Come on up in 5, 4, 3, 2, 1. Shh. Let's see here. There we go. Thank you so much. Okay. Alrighty, let's see here. Milo, were you able to come up with a ratio to represent how many insect larvae are allowed depending on how many grams of berries we're talking about? Compared to? Awesome. 4 larvae for every 500 grams. Very good.
Have you seen the TV show Larva?
Well, let's do this instead, please. Addie, shh, shh, shh. Addie D, can you give me an equivalent ratio for that? Shh, 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 shh. How about this? I'm going to tell you right now, Addie. This is just like reducing fractions, or actually, you can even reverse reduce it. Could you? Is there a factor in common with 4 and 500? 50? Oh, I don't think 4 has got a 50 in it. But I think you're on the right track. So wait. I see what you mean. Hold on. Let Addie think. Addie, I think what you're trying to say is you're trying to turn 500 into 250. How could I turn 500 into 250? I'm glad we're talking. Can someone help us out? How can I turn a 500 into 250? Tice.
You can divide it by 2.
Yeah. So, Addie, if I divide 500 by 2, that'll turn it into 250, but I have to do the same thing over here. That means it's allowed to have 2 larvae for every 250 grams. You could have also multiplied by 2, which I think is actually more interesting. That's 8 larvae for every 1,000 grams, which is a kilogram. Which, by the way, is a lot. Like, a kilogram, guys, a kilogram is like almost 2 pounds. So in order to eat that many larvae in a sitting, you're eating like 1.5 pounds of fruit. You know what I mean? Perfect. Table A. Okay. I need you guys to make sure that we can also focus on our learning goals. Again, I think it's fun to talk about these things, but I want to make sure that we're also getting where we want to be. And I'm really looking for better behavior from some of those folks on the moon team, because right now it's not really cutting it. It's like one's fine and the other's not. One's fine and the other's not. See if we can fix that. Luke, what would be a rate that you could do for this? Mm-hmm. Mm-hmm. So that would be 1/125th larva per gram. Or I think maybe makes a little more sense, 125 grams per larva. So that's the trick. just make sure that when you eat fruit, you eat less than 125 grams. Yeah, I know. It's bad luck, right? Okay, here comes the next one. Let's see here. Chocolate. Mmm. Hey! Oh boy! Chocolate! Yay! Did you know that the FDA allows a ratio of 60 insect fragments for every 100 grams of chocolate? Yum, yum, yum. Uh-huh. Guys, that's why they call them hugs. It's the bug giving you a big hug. Anyway, actually, I'm going to tell you guys right now, organic chocolate is probably the worst of it because they don't spray it for bugs. When I say teach, hey, bugs are organic. When I say teach, I want you to say, okay, write this as a ratio and a rate. Come up with an equivalent ratio and rate for each. Here we go. Yum, yum, chocolate. Teach.
Yum yum chocolate.
Oh boy, chocolate.
I don't like chocolate.
Hey, Penny, whatever you got to tell yourself to fall asleep at night is fine. Okay? It turns out, Thomas, it turns out that's false. That does not happen. Yeah. I know. Think of how many insect fragments you've eaten. Think about that. Yeah. I don't know how many grams. Maybe this is in here. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Thank you very much, guys. Appreciate that. That was everybody that time. Thank you. I appreciate you guys. Let's keep a good thing going. In the interest of time, guys, again, you would do like 60 to 100, which is the same as 6 to 10, 3 to 5. There's a lot of ways to do that. 100 divided by 60, which I think is, I forget, but it'll be how many grams of chocolate it is per insect fragment. Let's do the next one. I want to get as many of these as I can. Peanut butter. Peanut butter. I prefer crunchy peanut butter myself. Where do you guys stand? Point up for crunchy, point down for smooth. What do you guys like? I like it crunchy. Extra crunchy, please. Okay, here we go in 5, 4, 3, 2, 1. And by the way, sometimes the crunch isn't just coming from peanuts. Did you know the FDA allows a ratio of 30 insect fragments per 100 grams of peanut butter? Write this as a ratio and a rate and come up with an equivalent ratio and rate for each. Teach! Sit down, please. Math, please. There you go. That's perfect. That's exactly right. Go ahead, guys. Let's get the math down. Get the math down. Get the math down, everybody. We've got more to learn.
Wait, so does that mean there's insects and races?
Yes. Oh, doubly so, because that's got chocolate and peanut butter. And the chocolate's allowed to have more insect fragments than the peanut butter is. So to get the double stuff. You guys have, there you go, perfect. Thanks, guys. Okay. Can I get you back up here in 5, 4, 3, 2, 1. Next. Boxed cake mix. Stir out any lumps. Make sure you stir out all the lumps. I'm just saying made from scratch cake is better. But anyway, did you know the FDA allows a ratio of 75 insect fragments to every 50 grams of cake mix? Go ahead. Let's get to it and teach. Make sure you stir out all those lumps. All those insect fragment lumps. Stir them out. Stir out those insect fragment lumps, please.
It's Penny's fault. That is my fault.
Alrighty. Can I get you guys back up here in 5, 4, 3, 2, 1. I'm trusting that you guys are doing that. On to the next. Mushrooms. I love mushrooms and spaghetti sauce. Did you know the FDA allows a ratio of 20 maggots for every 15 grams of dried mushrooms? Yeah. Let's write that as a rate and ratio and come up with an equivalent one for each. Teach! That's protein. What's that? Like a baby bug. Like a baby fly. Okay. Can I get you in 5, 4, 3, 2, 1? Those of you at home, you're going to want to pause these as you go. Those of you here, just sit back and enjoy them. Here's what was coming next. Popcorn. Don't do it. I love popcorn. Sorry, everybody. The FDA allows a ratio of 20 rodent gnawed kernels to every 1 pound of Fun Pop popcorn. Like a rodent chewed on it. Write this as a ratio and a rate. Pizza sauce. No, not pizza. Sorry, everyone. The FDA allows a ratio of 15 fly eggs for every 100 grams of pizza sauce. Macaroni pasta. Can't make mac and cheese without it. FDA allows a ratio of 4.5 rodent hairs to every 225 grams of macaroni pasta. And that's all I got for you. That's it, guys. There's no self-assessment. Enjoy your dinner tonight. Have a great